Well, hello. These videos will cover a tutorial or a lesson on how to use a new syntax, which is called commonly for loops, or looping in general. Um, First of all, let's talk about writing a program to just draw a few lines in processing. 25, 0, 25. Height, so our first line will be drawn at an x coordinate. This is x and y, x, y, and this is the second coordinate, x, y. So to this, from this point to this point. So 25x at the top of the screen, y, and 25x at the bottom of the screen, height, y. So we'll just draw one line first. And this program will run, and it just looks like that. Okay. Well, let's copy this and do two more. We'll say we're going to have it be at 50 and 50, and then at 75, 75. Okay, well, so there's our three lines. But what if we wanted to do like 50 lines? That would start to get annoying to do all of this math. So we can see, though, that there starts to be a pattern. Our first line is at 25, then at 50x, then at 75x. Well, it would be nice if we could create some thing inside code to just take care of recognized patterns like this when you want to do something over and over sequentially with some sort of value that gets changed little by little and then figure out a stopping point. So the way we do that is what's called a for loop. So I'll just comment these things out so you can see. So two forward slashes just comments things out. And so we can write what's called a loop to do this. We just set up a counter variable, commonly, well, we'll name it in this case line x. And we'll set that at the beginning. We want the first x coordinate to be 25. And then we'll say, we'll then set an end condition. We'll say go as long as this is true. Okay, so go as long as it is true that line x is less than or equal to 75. And each time we proceed with this code that we're going to write, we want line x. You can see it goes up from 25, 50, 75. So that's a difference of 25 each time. So let's just say we want, every time through the loop, we want line x to be incremented by 25. So then, just like you would with an if statement, you write these braces, and this, so then I'll just finish the code and then we'll talk about exactly what it's doing. So we want it to go from line x to, at a y coordinate of 0, again to line x, but a y coordinate this time of height. And if we run our program, this will execute the exact same, or it'll result in the same outcome as the first three lines of code. So what is this exactly doing? Let's slow down and look at each part of the process. So right here, we build a new variable, and we're doing it within this for loop, so it only exists inside this for loop. So if we went down here and we tried to set the value of line x to something new, like 65, the program wouldn't allow us to do that because this line x variable only exists inside this loop where we have created it. Then the second condition after the semicolon, the first semicolon, is we want the loop to continue repeating as long as this is true, as long as this condition is met. And then the third thing is we want each time through the loop, this is how we want to proceed. So we know that we need to bring the initial value, 25, towards the concluding value, which we want it to be 75 in this case. And each time, so then it does this code at each of those times. So if we walk through it, the first line it draws is at line x 25, 25, with a y of 0 in height. Excuse me. Next time, it goes up, and then we increment this. So we add 25 to line x. Now the value of line x is 50. for this time through the loop, and we do this check after we increment it. We say is 50 less than, or the compiler does that, is 50 less than or equal to 75? It is. So then it executes this code. And then again, it goes up to the increment condition, proceeds with this, so adds 25 to line X, whatever is currently in line X. Currently, line X's value is at 50, it goes to 75, and then the program will check this condition again. And yes, 75 is less than or equal to 75, so that returns true. And then it goes and it draws the line for a third time. Then it goes and increments this again. So it adds 25 to the current value of line X, which is now 75, making this line X have a value of 100. And it does this check. Is 100 less than or equal to 75? No. So it skips executing this code and continues on down the program if there was other code, or in our case, just quits. So why is this valuable? Well, let's set up a situation where it's different. So I'm going to say, let's make it 400 by 400 instead. And this time, we're going to have line X start at 2, and we want it to go as long as line X is less than the width. And we're going to increment it by 2 each time, and we're going to just keep all that code the same. And so now, what's going to happen is that we just drew 200 lines very quickly. Or we could say, let's set this to 3 and have it draw a line every 3 pixels. So now it'll be a slightly less kind of jarring pattern. I think I'll do 5s now, and you can see that it will change every time. And you know, we can change, so there it is. Or if we wanted to change the orientation so it draws horizontal lines, check this out. So let's do line Y instead, and we just name these things so that we remember what we want them to represent. And so line Y is going to go in the Y coordinates position, so line Y, and this will now be width, and line Y here, and we need to go until it's as long as it's less than the height. And now if we run our program, it will draw horizontal lines instead. So pretty quickly the value of loops becomes obvious, and they're incredibly common as kind of a base syntax or base, like, it's like a language building block of programming, and you really need to experiment with it to become very comfortable with how to use loops, and we'll do that in the subsequent videos.